Welcome to lecture 51, which is on various components of a GIS. In this lecture, I'm going to explain what are the different components, what is their utility, and how we can develop an effective GIS in the organization. So we start. If we look at this particular figure, there are six important parts of a GIS. First one is the hardware. You should have a proper hardware with the up-to-date specifications so that you can do the fast processing of the data. So as far as possible, the latest hardware devices can give you very fast results when you are dealing with a large data set. The second component of it is the software aspect. So we have to either develop our own software or we have to use the available software, maybe the commercially available software or free open source software. Then the network is required, which is the internet connectivity or networking with the other data sets so that we can use the data from the internet. A lot of data is available, we can use the data from the other sources. The next important component is the data. A lot of data is required and this data will come from the different sources, and this is playing very important role because the quality of the data which matters a lot in the analysis part. The next component is the procedure. What procedure we are adopting in order to derive the useful results, in order to integrate the data, in order to carry out the analysis from that data. And the next component is the people. The experts who are working on that particular application problem, how they frame the problem, how they frame the rules in order to derive the useful results for that particular application. So people should have a good knowledge of using the software, a good knowledge of creating a database, and good knowledge of integrating these together. So this is all shown in the diagram. We have hardware component, the software component, and the digital data products from the different sources. Then there are different methods, there are people, and they are all networked together. So these are different components. If we are talking of the major subsystems of a GIS, in a layman language, we have a input system, we have some kind of a database management system, some analysis system, and finally the output system. So this is shown here from the real world. We abstract the information. So abstraction of the information, acquiring the data from the real world. Then there are some software tools, and with the help of that software tool, the data could be represented in the form of the spatial maps and also the tabular data. When we have a lot of tabular data, then there is a database required because you have to manage the entire data into their database. So your entire data, the spatial data and the attribute data will go into the database, and the software tool will actually be used to carry out the analysis. So here is the manual intervention required, where the software is to be directed to function according to the given knowledge, according to the given rules, and then create some output system which can be implemented on the real world itself. So from where we started, we closed at the same point. If we see now one by one these components and what is their utility. So first component was the hardware part. Now this is mainly a high-speed computer system, a high-speed graphical computer system on which the software will run. So it might be a workstation, it might be a desktop or a server based or a cloud based. So this is the latest is the cloud based, because if we cannot procure very costly workstation system, then we can take the services of the cloud based system where we can process the data, we can use that system. And some of the hardware systems we are aware when we are using any computer, as a matter of fact, for processing the data. We have the motherboard, we have hard driver, we have the processor, graphics card is required very much because your lot of data is the graphical data. Then in addition to that, which is required is the scanner digitizer. You may not require this in other applications where you are using the computer, but when you are carrying out the GIS based analysis, then there are a lot of maps which are paper based maps. Atlases, they have the paper maps. Then the thematic maps, topographical maps which have been prepared by various government agencies and organizations, they are available in the form of the paper maps. Then there are reports where you have the data in the form of the paper map. So scanner and digitizer will give you the flexibility that you can club that data along with the other digital data. So you can use this data after converting the hard copy products into the digital products. So you will learn how the scanner and digitizer would function in that case. Printer and so on and so on. Maybe you require a web camera and other things also in addition to that. So these are these different components, hardware components, which are required in order to develop a GIS system. So we know that if we have to perform faster, if we have to process our data fast and our data set is large, or in other words the big data, then what we require is we require these hardware components with the higher capacity, a greater capacity, and with the highest specifications, so that the processing time is much faster, and graphical information which comes out on the screen is also faster. So these all component will function together so that the GIS software which you are using, it runs smoothly and gives you the quick results. Now the next component is the software part, and the software is providing you the flexibility to create the data, to carry out the editing, to carry out the spatial analysis from that information, or to carry out the interpretation or manipulation of the data or extrapolation of the data. So a lot of things can be done with the help of the software. So large number of softwares are available. We can make a query from the data sets, we can edit the data, we can run display GIS database. Now this particular software has additional feature, which is the relational database management system. So this I will explain more in detail in a separate lecture, but this is the database system which is used to store the huge data in the tabular form, and also use this entire data sets to make complex query from the database system. Now the example of the software could be, you must have heard very popular software like ArcGIS, ArcView, QGIS, Saga, GRASS, MapInfo, Atlas. So these are some of the examples of the software which people are using for different kind of analysis work. Now if we further see what are the essential components of these software which we want to procure, or we want to develop, or we want to download the freely available. We have the capabilities of GIS work. So GIS tools should be there which can support and browsing of the GIS data. Then as I told you, the relational database management system is playing very important role, not only to store the GIS data, but to carry out the retrieval from the entire data sets into depending upon our query systems, depending upon the selection of the part of the data set. So we can retrieve the data very quickly from this huge data sets. So this RDBMS capability should be there. Then there should be a query tools, because this is one of the important function of the GIS. Once we have several layers together, several thematic maps together, and we want to make a very specific query, we want to make a very complex query, then manually or using any other software, it is just impossible. But when we are using the GIS software, because every data is especially linked together, so we can make that query very fast. So you should have a query systems. We can basically use some kind of a standard query language, or some we can develop our own language systems and club it with the query tools. Then you should have a graphical user interface, popularly known as the GUI, and this will help the user and the software to interact well together when the graphic interface is there. And the layout, once you have carried out the analysis, the map should be prepared from the results. So a good layout is required to be produced. You have to show, for example, the boundary of the map, you have to show the latitude, longitude, the north direction, the scale, the legend. So a good layout should be prepared so that the map ultimately becomes readable. So that should be the capability to represent the output from the data. Now this shows that there are commercially available GIS software. So this is not a complete list, but this is just an example so that you are aware what are the different commercially available software in the market. So the first one, for example, is here is the ArcGIS, which has been produced by the ISRI, Environmental System Research Institute, California. Quite popular software amongst the GIS community, because it is very much flexible, and it can do lot of things which probably you cannot do in other software. So this is that's why very popular, easy to understand. Then we have a software called GeoMedia, which has been developed by the Hexagon Geospatial. Then there is a software called the Map Info Professional. Then Global Mapper is a software, Manifold GIS, Small World, Bentley's Maps, Map Viewer, and Surfer. So these are some of the names of the commercial GIS software which could be used for analyzing the data and carrying out the GIS based activity in the organization. But if you don't want to spend money on buying the software, because the disadvantage with those could be that some latest version if comes in the market, then probably you have to again spend a heavy amount to procure those software. So there are options available, particularly if we don't have enough funds to procure those software, and these options are the open source GIS software. So there are plenty of open source GIS software available which can be downloaded and we can work together. So GRASS GIS, in fact, which was developed by US Army Corps of Engineers, this is a complete GIS package in itself. Then another one could be the Saga GIS. It is a hybrid GIS software. It has the unique application programming interface and bundled with the exchangeable module interfaces. So that is the advantage. Another popular software, open source software, is the Quantum GIS. This is running on the Linux, Unix, Mac operating system X, and Windows also. So a lot of people are using the Quantum GIS because it has a good option actually to create a web GIS also. Then Map Window GIS is another open source software. ILWIS, which is called Integrated Land and Water Information System, developed by ITC Netherlands. This is again quite popular amongst the researcher to use it. Then Jump GIS or Open Jump, these are other software. So again, this is exemplary list, the very long list. if we search what are the open source software. So the advantage of these is that immediately you can download and start the work, and even the data, some of the satellite image you can actually download from the free open sources, and you can carry out some kind of a analysis work, some kind of a research work. Lot of PhD thesis, for example, have been done using open source data and open source GIS or image processing software. So you are not spending really much money even if you want to carry out a good level of research. But the disadvantage from this open source software could be that everything whatever you want to do, you may not be able to do, because some of the options may not be available to you which are available in commercially uh, buying software, when you commercially buy the software. So commercially available software has more value in the sense that when you enter into your professional career, probably you will have to work on those commercially available software which are popular worldwide. So the employer will definitely ask you whether you know those software or not, and you have to learn that software then afterwards. So some has some disadvantage and some advantages are there as far as the both kind of software are concerned, commercially available and open source GIS software. So coming to the third part of this is the geographical data. This is the another component of the GIS. So the data will have actually three components. One will be the geospatial maps, which we can show graphically in the form of point, line and features. The other could be the attribute data. So if we are showing a building, the information about that building, how many story building are there, who is the owner, what is the area of that particular building, and who is living, when the building was constructed. So these could all be the attribute information about that building. And metadata is the data about the data. So it describes the information about the geospatial and the attribute data, that what was the year of the satellite image, which bands of the satellite image was used, when was the field data collected. So it all gives you that information. So basically there are three broad components of the geographic data. One is the map, which we call it the spatial data. Another is the attribute data, which is normally represented in the form of tables, and there is a metadata, the information about the data which you are showing. Now, if we see the further the characteristics of the data, it is very important part and very expensive component of the GIS activity, because it is known as the fuel for GIS. Actually, GIS is said to be the hungry of the data. So it needs more and more data so that you can carry out better and better classification and analysis. Very accurate results you can get if you have more data into it. So you have to create. If it is not available, you have to create. Once you are creating the data sets, you are spending up more time in creating the data sets rather than analyzing, spending the time in the analysis part. So the, as I told you, that it has a spatial component and it has attribute data. So you are creating the data in the form of various graphical maps showing point, line and area features, and attribute table of each of these features would be there. So there could be many tables, not just one table, and there could be many maps, graphical maps which you are showing. These graphical maps which you are showing in the form of the spatial maps, they could be either the vector map or the raster map. So you will learn about this vector and the raster maps more in another lecture. So these are the two different broad categories of the graphical data. So vector is the data which has a magnitude and direction, and the raster will be the grid based information, pixel based information, like satellite image. So these are the different characteristics of the data product. Your data should be very accurate, error free and updated. So if you have the updated information, it is better to work on the updated information so that we can use it for present planning purpose. So this spatial data, sometimes it is also known as the geospatial data because it is related to the earth surface and it is related to some coordinate system. So these are the real world coordinate systems to which the spatial data is located, and these entities to which these are referenced could be a latitude and longitude coordinate system, or it could be some xy coordinate system, or like is attached to the street address or administrative unit. So this is all our the spatial data which we are using in the GIS, and everything is linked to the real world geographical coordinates. In this slide, you can see that from the real world, a piece of the ground surface is shown. That real world, the many maps like elevation data is shown, land use, land cover data, land parcel data, and flood zone maps are shown. So likewise, you can create different layers, you can georeference them together, and then you can have attribute table for each of these maps. So you have this spatial maps and then the attribute maps together, so that you can create a GIS database. Now the attribute data is the information about the features which you are showing. So as I am showing you in the previous slide, the land parcel. So if I give the information about that land parcel, who is the owner, what is the type of the crop there, what is the area and the dimension of that, that is all the attribute data which I can show of a particular land parcel in the tabular form. So one has to create this data set. The information might come from the different sources, including the field visit. So you can actually link this attribute data to the spatial objects. So examples are given like census data by administrative unit. So in the administrative unit, you can show some census data, land parcel ownership records, or soil or vegetation characteristics in a particular area, information about the building, road quality information. So this all that data, if I create in the form of a table, this is called attribute information and attribute data. Now this attribute data and the spatial data, it has a link together, and that link actually has been shown. So you can have several attribute tables like here population data, degree days, and precipitation climatic data. So three tables are shown together, and once we have the three tables together, we have to manage this database with the help of the database management system. And also this data I have to link with my spatial maps. So spatial maps I am showing in the form of the graphical data. So in other words, there is a two-way communication. They are all linked together. So from spatial data I can link the attribute data, and from attribute data I can link the spatial maps. Now they, as I told you, that they are very much related to each other, and if I if I show any record in the attribute table, select any record in the attribute table, this will be highlighted actually here. For example, 2003, the object ID 2003 had been highlighted. So if I select object 2003, that will be picked up in the table also. So that is all two-way communication. So these data, spatial maps and attribute data, when I create in my GIS environment, I can use existing maps. So the different kind of maps, topographical maps, thematic maps, which have been prepared by various organizations like Geological Survey of India or Forest Survey of India, or maybe PWD or Irrigation Department or Water Resources Department. I can use images. So these images could be aerial images or the satellite images. So latest images one can use to create the data from that. Then there are digital databases available. So we can use those digital database available which has which have been created by others also. Then spreadsheets, if the data is available in the form of the Excel sheet, spreadsheets, this can also be used in the GIS, or if the data is available in form ASCII, that also. So there are different sources from where I can take the data as spatial maps and attribute data and create a database, perfect database in the GIS. Now, when I say the spatial maps or spatial data I can take from the different sources, there are two broad methods of taking that particular data, and one is the primary method, another is the secondary method. So primary method could be ground survey, land surveying, or available maps, or using aerial photograph, using satellite images, or the data which has been collected from the GPS or laser based technology. So this is all the primary method of acquisition of the data. But the secondary method could be that somebody else has collected that data. It is available in the form of the maps, in the form of the reports, in the form of the atlas hard copy data. So we are doing a process called digitization and scanning process. So we learn it in another lecture how this digitization and scanning process would help me to create the data from the secondary method. So these are the two broad methods of creating the data set. So as we know that a large quantity of maps are available which have been prepared by various organizations from time to time. It could be a topographical map, it could be map showing the geological characteristics of the area and different rocks and type, the forest maps, water resources map, road or rail map, habitation map, and likewise. So there are different organizations which are involved in creating their own maps for their own use. Now, there are ways to collect the data from the ground, um, either by the field survey method or using some kind of a instrumentation. So as you can see on the ground also, we can carry out total station based work to collect the data. We can use global positioning system or LiDAR survey or ground penetrating radar GPS based survey, or it could be a meteorological data or demographic data or temperature data. No, we can collect the data from the ground, from the field, and use some kind of a instruments which we are using in geomatics engineering to collect the data about the earth surface. So we know that aerial photographs and remote sensing images are the good source of information of the ground. They will cut down the field visits and provide you the data of a large area in the shortest possible time. So we can use latest aerial photograph. If we don't have latest, then we can supplement the information with the high resolution satellite images taking the latest, and further if we want very detailed information and updated information, we can have UAV and the drone images. So these are the different kind of data. Now this data has to be input to the GIS, because as I told you that the data collection and data input is the most laborious, very intensive, very tedious and very task consuming when we are developing a GIS, because at present we don't have any such system available where all the data is available to me, whatever I required for my study. This is available to me from the different agencies. I can straight away develop the tool, develop the technology and carry out the analysis from the data. So we have to create the data set, generate the data set and give this data input to GIS, carry out the georeferencing work so that the entire data is georeferenced together. So this takes actually a lot of time. Sometimes you have to do the transformation of the data also. So this is a major bottleneck when we are applying the GIS for our application, for our project planning purpose, because the data is not readily available in the desired form what we want, or it is not updated, or it is available at a different scale, or we don't know the quality of the data, we are not sure about the authenticity of the data. So that is why this is creating a bottleneck. Now the as far as the time is concerned, if we have to carry out a project, then 60% of the time is spent actually in creating the data, in inputting the data. Only the 40% of the time is there for developing the tools and carrying out the analysis work and checking the accuracy of the work. So, this 60% is a huge time which is required. Many commercial GIS operations now generate most of their revenue through the data input only. So, the data input has become very important component of the GIS. Now, it is essential, it is necessary that we have to find out the ways and means by which we can reduce the cost and maximize the accuracy, reduce the time, reduce the cost to input the data so that we can maximize the efficiency. So, for that purpose, it is important that we automate our all the process, all the methods as much as possible. And but automated methods sometimes can be more time consuming because you require then very large quantity of editing. Like if you take LiDAR data, if you LiDAR survey, carry out the LiDAR survey, then it will actually have the entire data with you for every object which was present on the ground. So then editing is required in order to find out the data which you don't require in your analysis, in order to delete that data, in order to carry out the editing process. Source documents may be often redrafted actually to have more rigid quality requirements of the automated input. So, sometimes the automated input in order to have the automated input, then you have to modify the source document. And sharing of the digital data is one method and very effective method where we can reduce the time, we can reduce the cost also. And this was one of the prime objective of National Spatial Data Infrastructure or the National GIS mission, that we share the data, whatever data is produced by the different government agencies, we can share the data so that we reduce the time and the efforts in creating the data set. So, more and more spatial data is becoming now available in the form of digital data sets, so that now we can use that directly into the GIS. And this is one of the good point of the digital India, that the entire information is going on to the digital platform. Now, this data input will involve encoding, decoding and locational data, informational data. So, location data is the data which is linked with the coordinate system on a particular Cartesian coordinate system or lat-long systems. The source maps which we are using from the different sources may have different projection systems, may have the different scales, may have the different error present on it. So, we have to consider all that when we are using them together. Different maps have to be transformed to a common coordinate system, to a common datum system, and the attribute data is stored in the form of a database management system. So, this is all about the input data. Now, when we are using the data, we have to ensure the quality of the data product also. So, this shows that the data quality versus the data cost. If we want higher quality of the data, naturally the cost is going to be up for that data product. So, it costs money. That is what it says. Then the management of the spatial data. So, we have textural data, we have the raster data, we have the graphical information, polygon data, points data, parcel data. So, this is all data, the entire different variety of the data is to be managed into the GIS system. Now, when we say the data is to be managed, what is the meaning? The broad meaning is that storing the data and retrieval of the data or the part of the data when I require, organizing of the data, transformation of the data from one form to the other, data conversion and data representation. So, these are all the components of the data management when we are creating. So, this slide shows here that we have the framework of the data and we have here the thematic data. So, several layers are there together. Now, because they are geographically linked and registered together, we can all use them effectively. Very large number of maps, we can use them together. Now, this database development, when you are developing the database for a particular application, now you have to collect the related data, give the input to the data, and this is quite time consuming, and this database development has to be perfect so that you can carry out the accurate analysis and the query system from this. When you are using the geographical database, we can use for large number of activity. Once the database is perfect, we can carry out spatial analysis, spatial planning, spatial management, map generation, query development. So there's a long list actually. When we discuss how to make use of the database, we'll discuss in more detail, but a lot of things can be carried out with that. Now, as I told you, the map features are linked now with the tabular data. So on the same screen now you can see the tabular data is appearing, attribute data is appearing, and the spatial maps are appearing. And if I select a particular polygon, a particular unit, this is highlighted. So first three lines, as you can see in the database, they are highlighted, and these are indicating the yellow color which I have shown on the graphical maps. So there is a two-way communication. So I can make a selection with the help of the data in the attribute table or in the spatial data. Now, the other component is the method. We have to develop a suitable method from this data set, so that using that particular method, I can carry out the analysis of the data. I can visualize the data in the 2D or 3D, or maybe the animation of the data. I can reveal the relationship pattern. I can use the data for trend analysis. I can use the data for forecasting the future. So the methods have to be developed so that we can very efficiently make use of the data and carry out the desired work for the application part. Then the last component is the people. So they are people are the user of the GIS. They are running the GIS software, carry out the analysis. So people are required for multidisciplinary background, because as I told in the previous lecture also, that this is a multidisciplinary tool which could be applied to many application area. So we require experts from the different background, so that they have the knowledge to integrate the data into some rules, using some criteria in order to get the effective output. So people are the main actually component of the GIS for its successful implementation. Now, when we say people, they are the technical specialists, they are the end user. There are two kind of a people: end users of the results, and also the people who are actually technically qualified how to make use of this software and derive the results. So this is showing that GIS professionals are powering the geographic enlightenment. So they are creating innovative solutions. People are learning and teaching the patterns. They are showing what is possible from this, and they are applying the GIS everywhere. So it is the people, it is the experts, it is the knowledge which is actually of the people which is important to make effective use of the GIS. So this is, I think, all. Thank you very much.